chef. KT. Two things I want to accomplish today. First, I want to solve exponential equations. Okay? Second, I want to solve logarithmic equations. The downfall of solving logarithmic equations is that logarithmic equations come in three different forms. So really, my two things to do today is really four things to do today. Okay? But we're fine. We can handle it. Okay? Now, I am a step kind of a guy. Okay? So I'm going to give you the steps to solve these different problems. Okay? All right? So if you are an exponential equation, before you even begin to figure out how to go about solving the equation, you have to figure out if it's exponential, if it's regular, or if it's logarithmic. Okay? So the easiest way, or the easiest one to see, is the logarithmic equation. Because you will see the word log, or you'll see the two letters ln, for natural log. Okay? So that's the easiest one to pick out. Okay? The second easiest one to pick out is an exponential equation. What makes an exponential equation exponential? Or what's the one classification that has to happen in an exponential equation? Or one. Is there really two? What about the exponent? More so. Because x squared is not an exponential equation. And I have an exponent. The variable in the exponent is the first primary condition. The secondary condition is what about the base? The base has to be positive. Okay? So most important, the variable has to be in the exponent. Secondary, the base has to be positive. When we're solving equations like this, your bases will be positive. We don't have to worry about that one as much. Okay? Alright? So, if it's not, then you go about doing it the way that we did it before. The way that we've solved equations for the last weeks and weeks and weeks. Okay? Alright? So, this is which kind of equation? Regular, exponential, or logarithmic? Why is it exponential? Variables in the exponent, this is exponential. So the very first thing that we are going to do is we are going to isolate the exponential term. So nothing in front of it, nothing behind it, nothing above it, nothing below it. Isolate the exponential term. Okay? So in this particular case, I have nothing in front, I have nothing below, but I have something behind, so I'm going to add 4 to both sides. That gives me 3 to the x power equals 10. Okay? I have isolated my exponential term. Nothing in front, nothing below, nothing behind, nothing above. All by itself. Okay? Then I'm going to go to step number 2. Step number 2 says that I am going to switch forms. So since I'm in exponential form, it will look like, oops, that's not a, I don't need that to be a D, I need that to be a B. That needs to be the base to an exponent equals some number, is the current form that it's in. That's exponential form. I need to switch that into logarithmic form. So that's going to become log of some base of a number equals my exponent. I'm going to solve exponentials by switching them into logs. Preview of things to come, how are we going to solve logarithmic equations? Switch it into exponential. Okay? That's how we solve these two. That's why they're paired together. We solve them by putting them in the other one. Okay? So this becomes log base 3 of 10 equals x. Then, I might have to, in this one I don't, but I might have to do some extra solving steps. Here the variable was just x. The variable term might be 7x plus 3. Okay, and then I'd have to subtract 3 from both sides, divide 7 on both sides, etc. Okay? So, but here I don't have to do any solving, so I am done. This would be the exact answer for it. Now, I'm an exact kind of a person. You might not be. So you would have to then go to your calculator and you would have to figure out what log base 3 of 10 is. So you'd have to use change of base formula from yesterday, excuse me, and figure out that the log base 3 of 10, or log of 10 divided by log of 3, or natural log of 10 divided by the natural log of 3 is, and we're going to round to 3 decimal places, 2.096. And then lastly, we should get in the habit of checking those answers. If you have one of those nice scientifical type calculators that has the ANS key, usually on the TI-30s, it's the shift of the negative key. You can leave it on your calculator and you can go 3 to the answer, and that gets you 10 if you leave it on your calculator. If you round it, you would get 3 to the 2.096. You'd get 10.0011-ish. And then you subtract 4, and you get 6. So you checked your answer. It works out. Yay for us. Okay? Okay. What I'd like you to do now is I would like you to solve those two problems. So, quick spot check. First off, this one is isolated. Number 1 is already isolated. Nothing in front, nothing below, nothing behind. Okay, so we can automatically switch forms with it. Log base 4 of 54 equals 4x plus 2. Now, here you got 2 different paths that you can go down. Both of the paths will get you to the exact same spot. Okay? You could figure out what log base 4 of 54 is right here. Okay? Log base 4 of 54 is 2.877. Okay? And you could go with that from there. Totally fine with that. Okay? All right? Or you could leave it exact. Okay? And then you would go through and you would subtract your 2 from both sides. So then that's going to be log, actually let's go this way instead. Let's keep our logs last. We're going to go negative 2 plus log base 4 of 54 equals 4x. And then I'm going to divide everything by 4. Oops, too far. Bless you. and then that gives me an exact form, -2 plus log base 4 of 54 divided by 4 is x. And then you can go to the calculator and figure out what that is if you want. Gets me, I get x here is approximately 0.219. And then I can plug that back in. 4 raised to the 4 times my answer plus 2 gets me 54. Yep, works out on my calculator, on my check. Second one, I'm going to add 3. That's going to give me 2e to the 2 minus 3x equals 14. Still not isolated because I have something in front of the exponented term. So I'm going to divide by 2. That gives me e to the 2 minus 3x equals 7. Now it's isolated, so I can switch forms with it. Log base e. Log base e is natural log. So this is the natural log of 7 equals 2 minus 3x. And we don't write log e or log base e or log, if you will. Subtract 2. So then that gets me -2 plus the natural log of 7 all over -3 is x. That would again be the exact answer. And -2 plus the natural log of 7 divided by -3, 0.018. Would be my approximate. Okay. Questions on those two? Good. Okay. Put your calculator down like. Okay. All right. So that's solving exponentials. Okay. So we're a fourth of the way there. Okay. Next one is solving logarithmics. Okay. There are 3 forms to solving logarithmic equations. The first form is if you have a single solitary log. Okay. So again, if you're in that case where you've got a single solitary log, then your first step is going to be to isolate. So you're going to isolate that log term. In this particular case, I'm going to subtract 3. Okay. Then, once you have that log isolated, you are going to switch forms. So now instead of going into logarithmic form, you're going to take your log and you're going to put it into exponential form. Okay. So in this particular case, what's my base here? Base is 10 because it's not written. So when it's not written, the base is 10. So this is 10 squared equals x minus 3. Now that you've switched forms, now you are going to solve your new exponential equation. 10 squared is how much? 10 squared? 100. Add 3 to both sides. And I get 103 as x. Okay. Now, in logarithmics, what are the two conditions in a logarithmic equation from yesterday? We had two conditions yesterday. Two conditions from yesterday for a logarithmic equation.
And the number is positive and b not equal 1.
So the base has to be positive and not equal to 1 is the first condition. What is the base of my log in this problem? In my original equation, what's the base of my log? 10, right? 10 is positive, 10 is not equal to 1. So we have satisfied condition number 1. Condition number 2? What else has to be positive? The number, right? The hashtag part has to be positive. Okay? So this part in here has to be positive also. If I plug back 103 into that, 103 minus 3 is 100, so that's still positive. Those are your first two quick, easy checks. Your base has to be positive and can't be equal to 1. And the argument, that part there, that yellow part is called the argument. The argument has to be positive. Okay? Log of 100, then, after I plug in 103, log of 100 is 2. 2 plus 3 is 5. Works out, so my answer here is 103. When you are solving logarithmic equations, you have to check them, because we will have extraneous solutions, solutions that don't work in logarithmic equations because of those two conditions. Okay? Try that one on your own. Log term is isolated. Switch forms. 4 to the 6th power equals 3x. 4 to the 6th power is 4096 equals 3x. Divide both sides by 3. And you get that. 4096 over 3. If I plug it back in, I have a positive base that's not equal to 1. I have a positive argument when I plug it back in. 3 times that gets me 4096. Log base 4 of 4096 is 6. So that is my answer. Okay? Form 2 of solving logarithmic equations is log equals log. Okay? So when log is equal to log, it's actually nice and easy. because you only got two things that have to happen in log versus log, or log equals log case. And that is, you gotta have equal parts. So your first check is the bases must be equal. Okay? So in this particular case, the base of 7 is equal to the base of 7. So that works out. The second thing that you have to check is that the arguments are equal. So 2 minus x has to equal 5x. Well, that's where the variables lie, so that's what we're going to solve. 2 minus x has to equal 5x. And then you go through and you solve and check that. I would add x here to both sides. That gives me 2 equals 6x. Divide both sides by 6. Gives me 1/3 equals x. I'm going to get the hiccups all of a sudden. Now, if I plug 1/3 back into my function, I already have bases that are positive and not equal to 1. So that condition is met. I just have to look at those arguments. If I plug 1/3 back into 2 minus 1/3, that gets me 1 2/3. Okay, so I'd have log base 7 of 1 2/3. Okay. On the other side, I'd have log base 7 of 5/3. Well, those are both equal, actually. 1 2/3 is 5/3. Both have positive arguments, so it's good. So 1/3 is my answer. Try that one. Log equals log. Bases are the same. Both bases are e. So then 5 minus 2x equals 5x plus 3. I would add 2x to both sides and subtract 3 from both sides. That gives me 2 equals 7x. Divide both sides by 7. That gives me 2/7 equals x. If I plug in 2/7 into my equation, 2/7 times 2 is 4/7, so I got the natural log of 4 3/7 there. On the other side, 2/7 times 5 is 10/7. 10/7 plus 3, well, that's going to be, this is 1 3/7. Plus 3 is the natural log of 4 3/7. Checks out. Works out. Love it. Okay. 2 seconds. Yep. Third form of logarithmic equations deals with when you've got 2 or more logs and some extra stuff. There's just some random numbers or some random variables floating around. Okay? Alright? So in that particular case, what you have to do first is you have to get all the logs on one side. Okay? So right off the start, you got to get all the logs on one side. Okay? Then, once you have all the logs on one side, like we have here, then you are going to use your properties that you had from yesterday, and you are going to condense into one log. So in this particular case, I've got log plus log. From yesterday, that's product property. So this becomes log base 3 of x times x plus 8 equals 2. Now that you've condensed it into one log with no extra stuff that goes on, then you can now switch forms. So this would be 3 squared equals x times x plus 8. You can solve (3 squared is 9). X times x plus 8 is x squared plus 8x. Because I have a squared term with a linear term on it, I've got to get everything onto one side. So I'm going to subtract 9. Zero equals x squared plus 8x minus 9. Then I need to factor. Two numbers that multiply together to be negative 9 and add to be positive 8 are positive 9 and negative 1. Then I need to set my factors equal to 0 and solve those. And then lastly, I need to check my work. Especially in these, I need to check my work. Because this is the most likely spot for an extraneous solution. Okay? So my original problem had in it as its first term, it was log base 3 of x. Actually, let me just rewrite it. So it was log base 3 of x plus log base 3 of x plus 8, and that was equal to 2. If I plug negative 9 into that term right there, is that legal? Why not, Henry?
Because the x in that one's the number of
the argument. Yep, you can call that the argument. Yep, the argument can't be negative. So I can't put negative 9 into my first term, so negative 9 cannot be an answer. I throw it out. Okay? If I put 1 in there, log base 3 of 1, that works out. Log base 3 of 1 is 0, actually. If I put 1 in the next term, log base 3 of 1 plus 8. 1 plus 8 is 9. Log base 3 of 9 is 2. 0 plus 2 is 2. So my only answer here is x equals 1. If you put negative 9 in there, then you didn't do your checking. You didn't do your diligence. Okay? All right? What I would like you to do now is I would like you to try that one. Step 1, get all the logs on one side. Done. Step 2, condense the logs down to 1. Log base 2 of x times x plus 1 equals 1. Step 3, switch forms. 2 to the first power equals x times the quantity x plus 1. Step 4 is solve that bad boy. Well, that's going to be 2 equals x squared plus x. That's 0 equals x squared plus x minus 2. That factors to be x plus 2 and x minus 1. That means then that x plus 2 would equal 0 and x minus 1 would equal 0, giving me x is 1 and x is negative 2. If I plug negative 2 back into here, that gives me a negative argument, which is bad. So therefore, that one can't happen. If I plug 1 back in there, log base 2 of 1 is 0. If I put 1 into the next one, log base 2 of 1 plus 1. 1 plus 1 is 2. Log base 2 of 2 is 1. 1 plus 0 is 1. 1 is equal to 1. Lots of 1s there. X is equal to just 1. Okay. Questions on that one? Another homework sheet for you today that will be due tomorrow.